the definite integral is the integral of the function from a to b, okay? And that allows you to find the area under a curve. For the minute, we're actually just going to get the definite integral. We're not actually going to find the area. We'll do that in the next section, okay? Now, a definite integral doesn't have your constant of integration. It doesn't have a c, okay? An indefinite integral has a constant of integration, okay? So we'll just do an example of finding the definite integral from a to b. These are called your limits of integration, okay? So it's from 1 to 5, okay, or something like that. So example 1. Evaluate the integral of 3x squared from 0 to 2. So what you do is you integrate it. So integrate 3x squared. 3x cubed over 3. And you're going from 0 to 2.
What's under
Here,
yeah.
this is a 0. 0 to 2. Okay, so just tidying that up, that is x cubed from 0 to 2. Now, to get your answer, you're going to fill in 2, you're going to fill in 0, and you're going to put a minus in between them. Okay? So your answer to that is 2 to be cubed minus 0 to be cubed. Okay, you're filling in your 2 and you're filling in your 0 instead of x. So 2 cubed is 8, 8 take 0 is just 8. Let's just do part 2 of that. So first of all, you're going to integrate this. When you integrate it, you get your square brackets. So integrate x squared. X cubed over 3 minus x squared over 2 plus 3x. Okay, you don't need the plus c here because you're adding on a c, and then when you're filling in your other limit, you're taking away a c, so they cancel. Okay, now this is going from 2 to 4. So what you're going to do is you're going to fill in your 4 instead of x, and you're going to take away your 2 instead of x. So fill in 4 first. And you're taking away your other limit. Okay, so your upper and your lower limit. Just throwing that into your calculator, you get 152 over 6 here minus 40 over 6 here. Is that okay? Okay, we keep going. Part 3. So we're going to integrate this. Before we integrate it, we need to change it to something that we can actually integrate. So root x is what? X to the power of a half. And it's underneath the line, so where does it need to go? Above. And what happens to the power? Great. So that's actually x to the power of minus a half. Now we can integrate it. So to integrate x to the power of minus a half, increase your power by 1, x to the power of minus a half plus 1 is a half, isn't it? X to the power of a half. And I'm dividing by a half. Dividing by 1, multiplying by 2. Okay, you're dividing by a half. Dividing is the same as turn it upside down and multiply. Okay, so you're dividing by 1, multiplying by 2. You can just put it over the half if you want and leave it like that. Okay, is that all right? Okay, so I'm going from 4 to 9. Okay, so that means fill in the 9, and then you're going to take away when you fill in the 4. So 9 to the power of a half is the square root of 9, isn't it? Square root of 9 is 3. 2 3s is 6. And 4 to the power of a half is the square root of 4, which is 2. 2 2s are 4. So 6 take 4, which is 2. Okay. So we are integrating cos 2x dx from pi over 4 to pi over 2. Okay, so let's integrate it first. Integrate cos, you get sine 2x over 2. Good. From pi over 4 to pi over 2. Okay, so filling in my pi over 2 first, you're filling in the top one first. Sine of 2 by pi over 2 over 2. Sine of 2 by pi over 4 over 2. We're not changing our calculator into radians, so what's pi? 180. Lovely. Okay, so you can just throw that all in, or you could tidy up a little bit, so I know that 2 and that 2 are going to cancel anyway. So it's sine of 180. Sine of 180 in the calculator comes out as 0. Okay, and 0 over 2 is just 0. I'll do it over here. Minus, that goes in there once, that goes in there twice. So 180 over 2. So that's sine of 90, which is 1. That bit there is 1, so it's 1 over 2. So minus a half. So your answer is just 0 minus a half, which is minus a half.